Hello everyone, so welcome back to Microeconomics. So in the previous lecture, we talked about how we define the implicit cost and the explicit cost for the firm and how we calculate the accounting profits and the economic profits. We also defined what types of production inputs to run a productions. So very quick review here. So last time we kind of mentioned that there are two key production inputs that the firm will have to use. So one is called the fixed inputs and the other one is called the variable inputs. So the fixed input is something that the firm cannot be adjusted and it's not related to the production outputs for that particular period of time. The variable inputs are the one basically related to the total quantity of outputs of the firm. When firms want to produce more or less, the variable inputs will need to be adjusted, and they can be adjusted during that specific time period. And we also talk about why is it important to define the fixed inputs and variable inputs in the productions, because it helps us to define what we mean by the long run production periods and the short run production periods. Well, as a review, just want to remind you, during the long run productions, there is no production input that it's fixed. So everything's are variable inputs. In the short run production, it's when the firm facing at least one or some of the production inputs that are fixed, so that the firm will have to make a decisions on the production based on what it's being fixed in the productions. Well, today we would like to actually use this one quick example to demonstrate the productions of the firm, and later to expand this example to relate to the costs of the productions. So we would like to first build our very first production model here by assuming there is a production by this hospital. So there are two things that the hospital will need to put into the back box in order to produce the final outputs. And in this case, we are assuming the hospital is providing a healthcare service in the market. So the hospital has two inputs here. One is the labor and the other one is the capitals. So labor refers to the nurses in the hospitals, and in this case we refer the labor as a variable input in the productions. Capital refer to the buildings. So in this case we are assuming the building is fixed inputs in this productions. So again, according to our definitions, as long as the production is facing some fixed inputs, in this case the building, we are basically analyzing the productions in the short runs. And here we have some variables that we would like to use to define our metrics in the study. So number one, we have Q here, define the total outputs of the firms, which is the total number of patients being served in the hospital. And L refer to the total number of nurses hired in the hospital, which is related to the labor. And K refer to the capitals, and capital is the hospital buildings that the hospital company rents in the market. We are going to calculate some of the metrics here. The first one is called the average product. So the average product, it's basically using the total quantity of outputs divided by the total number of variable inputs, in this case, which is labor. And we're going to also find this metrics here called marginal product, which is calculated by using the change of the total outputs divided by the change of the variable inputs, which is labor in our case. Well, here's a table that demonstrates the productions in this hospital. So first, we have to learn how to read this table. So as you can see, there is a first column here called fixed inputs, which is the capital. So the hospital will always have this one unit's fixed building that they are going to use to provide the service. So that's why the fixed inputs will never change. It will always have a value of 1. However, In this table, we are demonstrating how the variable input can be changed. So the variable input column 2 basically refer to how many numbers of nurses or labor hired for these productions. And Q, the third column here, is refer to the total outputs of the hospital, which is the number of patients served. And the fourth column and the fifth columns are basically calculated by using the number given in the first three columns. So as you can see, well, the first rows here actually say, well, fixed input is 1, variable input equals to 0, and total input equal to 0. So what it means is if we have one building but no one working in there, so no patient can be served. The second rows refer to the case where there is one building and one nurse worked in there, and this nurse can serve a total of 5 patients. And the third rows refer to the case where there is one building and 2 nurses working together in this building, and they combine to serve a total of 16 patients. And as you read it down from each rows, you will find a different combinations of the variable inputs pairing out with the fixed inputs in the productions. So one thing that's very important for you guys to note is in this production tables, we don't find adding one additional nurse actually increase the output by proportionally the same amount every time we add a nurse. So in this particular case, by adding one nurse in this productions, this one nurse can serve a total of 5 patients. However, adding one additional nurse, which is the second nurse add to this productions, the 2 nurses working in this one building not only just produce 10 patient service, but indeed, well, this time they combine to produce 16. And by adding the third ones, again, we are not adding additional 5 more patient service here, and neither 11s. We are actually adding 14 more patient services by adding the third one additional nurse in this productions. So now the question is, well, why? Why is it behave like this? And do we see some turning points in this production table? Well, indeed, there are 2 very important turning points in this production tables. And by looking at this table here, maybe we need some metrics for us to capture those changes. So the first things that we should note is we have the columns of marginal product, which is calculated by using the total quantity of outputs and the total quantity of variable inputs, which is labor. So we are using the Q divided by L equation to calculate the marginal products. The average products columns, which is the last columns in the table. And the marginal product columns, it's calculated by the changes of the quantity of outputs divided by the changes of the quantity of inputs, labor. So in this case, the marginal product is the one that's involved a little bit more calculations, because calculating the average product is easy in this case. To calculate the marginal product, let's say for columns 5, which is one building with 4 nurses, we need to use the total outputs for 3 nurses, which is 30 units, minus the total outputs of 4 nurses, which is 36 units, divided by the total number of nurse, 3, minus the total number of nurse, 4, and that's why you are getting the results equals to 6. Well, again, this marginal products and also average products columns are going to help us to find 2 very important critical points. And the first one right here that we would like to talk about is the one where the marginal products is going to keep increasing until some point it actually starts decreasing. As you can see, the marginal products has been increasing from the second rows to the third row to the fourth rows, but from the fourth row to the fifth rows, we actually see the numbers start decreasing. Well, the second critical point in this table is when the marginal product actually turning from positive number to a negative number, which happens on the 7th nurses. So when we look at the number here, the additional products that the firm can get from this one more nurse keep increasing and keep having a positive number, but at the 7 nurses, well, we see a negative number. And the marginal product tells us by hiring one more nurse in these productions, how many additional services we can provide in this hospital. And obviously, when the positive number turns into a negative number, that means hiring the 7 nurses is going to reduce the total amounts of services provided in this hospital. So that's why, well, it's actually negatively impacting the overall productions in the business. If we plot these numbers on a graph, we can easily see the turning points by looking at the marginal products curve or the total product curve. So the marginal product curve actually tells us when the firm hiring the 3rd nurses, only 3 people working in the hospital, the marginal products, the additional patients service that the hospital can provide by additional nurse will be maximized at the top point. However, it doesn't really mean that, well, the hospital has no reason to hire the 4th nurse, because hiring the 4th nurse still providing more patient services in this hospital, but it's just not as comparable to the 3rd ones. But another turning point here actually is interesting to evaluate is when the firms or this hospital hiring the 6 nurses, and they should actually seriously determine whether they should hire the 7 ones, because hiring the 6 nurses will still have a positive marginal products, but the 7 nurses in these productions will decrease the total outputs of the firm. Well, in this graph right here, we can also identify what we call the marginal productivities in these productions. And specifically, we want to divide them into 3 regions. The first regions here, when you see a marginal products keep increasing in the productions by adding more of the variable inputs, we call this ports, or this part of the graph, the increasing marginal returns of the productions. And we see the additional outputs will keep increasing by adding 1 additional unit of inputs. The second area here in green area, it's what we call the diminishing returns or diminishing marginal returns in the productions. This is when the firm adding more additional variable inputs into the productions, the total outputs by adding 1 additional unit of inputs will be less than the previous units. However, we're still producing more, but it's just not as efficient as comparing to the previous units. Well, the last area here in red color, it's what we call the negative marginal returns. And this is the area where the firms will never step into because, well, by adding 1 additional outputs, 1 additional inputs, the firms is actually getting less total outputs in returns. So by looking at this graph, you can kind of see how the firm's productions will behave in the short runs. And obviously, it's not always going to be a constant returns of the firm productions. And this, it's not just the case in this hospital. And indeed, this phenomenon here applies to the general productions in the world. We basically refer this phenomenon and given a name here in economics. Well, we call this the law of diminishing returns. So when firm hire workers to produce outputs based on the available resources, in this case, the building, many of which are fixed in the short runs, as more workers are hired, diminishing or even negative return can set in. So you can imagine in a very simple example, let's say you have a project that's due tomorrow, and you would like to work on this project. Well, you have yourself to work on this project, and you have 1 computer in front of you, and you would like to work faster. Maybe you can add another computer in front of you so that you can actually type some of the reports on 1 computer, and maybe using some software to produce a graphs on a other computer. Well, Adding one additional piece of equipment to your production is going to help you increase efficiency. However, by adding the third computer, the fourth computer, or the fifth, or maybe having 10 computers that you are working at the same time, it might not help the efficiency of your productions. So the production is an important component of the profits, but not enough to determine the optimal production's output, because maximizing profits take two sides of the business. We now investigate how the productions in the short runs actually looks like, and we would like to look at the cost of the productions. The cost of the production, it completely ties into its productions itself. So we study the productions of the firm because we want to know how the costs will be related to this behavior of the productions that we study in the short runs. Well, in economics, there are a few cost concepts that you have to know. So number one, we call this a fixed cost. So the fixed cost in the production basically refer to the total cost of the fixed inputs in the short runs. The variable cost, on the other hand, it refers to the total cost of the variable inputs in the productions. And number three, the total cost here, it's basically the sum of the fixed cost and the variable cost. If we put it into a mathematical terms, and also one more thing, the marginal cost, of course. The marginal cost, it's basically how much the firm will have to pay additional by producing one additional outputs. Again, to put them into mathematical terms, it might be easier for you to see how the total cost is being calculated and how the marginal cost is basically put into a calculations. So we will use these equations and trying to put the productions examples that we study into a particular case that we can study for the cost of the productions firm. So in this example, we are using exactly the same productions that we study in the hospital case. We have the quantity of outputs, Q. We have the level of capitals used, which is building, K. We have the total number of laborers, which is the number of nurses hired in this hospital, L. And we're given the information here. Let's suppose the cost of the fixed inputs in this hospital is $500. So that means the buildings actually cost the firm $500 every month to pay the rent. And we assume the variable cost for the firm to pay is $50. So that means for each nurse to work in this hospital for 1 month, it's $50 that the firm has to pay. Well, with this given information, now we can start thinking about how the costs will be calculated in these productions. Well, first of all, if you want to think about the fixed costs, well, fixed costs refer to the total cost of the fixed inputs. And since the fixed inputs will never change in the short runs, and we always have that one building that we have to pay the rent, so that's why the fixed cost in the short run is $500 at each level of outputs that the firm produces. The variable cost, on the other hand, can be changed. And the reason is because, well, the variable costs refer to the total cost of the variable inputs, and variable input can be changed in the short runs. So that's why at different level of outputs, firms will have to pay a different variable cost in the productions. The total cost, it's basically the sum of the fixed cost and variable cost columns. So the first row tells you even though the firm is not producing anything, 0 units, but the firm still have to pay the fixed cost, which is $500. As the firm increasing the outputs to 5 units, 16 units, 30 units, well, more of the variable inputs will be implemented in this productions, and that will add up the variable cost in the productions, and that's why the total cost will also increase. Well, lastly, we have the marginal cost. The marginal cost is the one that's confusing for most of the students study this cost productions relationships, but the idea is we are trying to use the difference between the total cost, which is 500 minus 550, or maybe the other way around, divided by the change of the quantity of outputs, or in this case, from 0 units to 5 units. So the change of the total cost is $50, and the change of the quantity of output is 5 units. And that's why we get the marginal cost here is equal to 50 divided by 5. If we want to calculate the next level, well, we're going to take $550 minus $600, which is the difference between the total cost, and we're going to use 5 units minus 16 outputs. So we get 11. So that's why the next level of marginal cost is 50 divided by 11. As you can see in this table, I try to keep the marginal cost into a fraction so that you can see how the number is getting from the table. Now we can derive these tables in this format so that we can see how the marginal cost will change and how the total cost, variable cost will change at different level of outputs. However, the terms productivity that we usually brought up, it's not what we usually use in economics to evaluate the efficiency in the productions. But you might want to know, well, what do we mean by productivities? So productivity basically refers to the terms that we used previously called average products. So for instance, let's say if we have two firms who are producing cars, let's say Toyota and Ford. Toyota hire 1,000 people to produce 15,000 units of cars, while Ford hire 1,500 workers and they produce 18,000 of cars. The terms productivity here does not refer to the total outputs of the firm. Indeed, the productivity is referred to the average products of the firm. So to basically evaluate which firm is more productive, you can simply use this very simple average product equations. Use the total number of workers. In this case, well, in Toyota, which is total number of cars that they produce, $15,000 divided by the total number of workers, which is 1,000 workers. And each worker can produce 15 cars in the Toyota plant. On the other hand, we have 18,000 units of car produced at Ford, and they hire 1,500 people to do it. And each worker basically produce on average 12 cars. So by comparing the two numbers here, we can now actually talk about the productivities of the firms. And in this specific case, obviously, Toyota is actually more productive comparing to the Ford productions. So the productivity is a very common term to use in a lot of articles. So just getting to know what it means, it's going to help you to understand how we define the productivities of the firms in the later chapters. Well, let's go back to the cost discussions here. So now we have an idea about the total cost, fixed cost, and variable cost. And we would like to know a little bit further. So in economics, the total cost is going to help us to understand, well, what is the sum of the costs in the productions. However, more importantly, we would like to study the averages. So there are three average cost concepts here. One is called the average total cost, which is calculated by the total cost divided by the quantity of outputs Q. And also we have the average fixed cost. It's using the total fixed cost divided by the total outputs Q. And the average variable cost using the total variable cost divided by the quantity of output Q. And we have one more thing that you have to know about the averages. Since the total cost is equal to the total fixed cost plus total variable cost, and if we want to calculate the average total cost, we can also sum the average fixed cost plus the average variable cost to get the average total cost of the firms. Sometimes we call the average total cost a per unit cost in the productions. Of course, the last one that we cannot forget about is the marginal cost. Well, let's take a look at the average costs in a table. So think about the previous example that we did. If we are going to calculate the average fixed cost, average variable cost, and the average total cost in one table like this, you have to always know where you're going to get those numbers from the table. In this case, because we already defined the fixed cost, variable cost, and total cost in the previous table, I would like to just go over where we get the number for calculating the average fixed cost, the average variable cost, and the average total cost. So the average fixed cost can be calculated by using the fixed cost columns divided by the quantity column. So as you can see, 500 divided by 0, well, anything divided by 0 is not a number, so we do not have any number to describe on the first row. However, the second rows will allow us to use 500 divided by 5. And the third row, 500 divided by 16, and so on. On the other hand, if we want to calculate the average variable cost, you have to use the total variable cost columns divided by the quantity of output columns. Well, the same idea. 0 divided by 0, anything divided by 0 is not a number, so we do not have that number on the first row. And starting the second ones, we have 50 divided by 5, and then next one, 100 divided by 16, and 150 divided by 30. The average total cost, on the other hand, it's using the total cost columns divided by the quantity columns. So 550 divided by 5, 600 divided by 16, 650 divided by 30. Well, if you look carefully, you can also calculate the average total cost by using the sum of the average fixed cost and the average variable cost. So in this case, if you look at the AFC and AVC columns, you use 500 divided by 5 plus 50 divided by 5. You are also getting 550 divided by 5. Well, at this point, maybe you are confused about, hey, what's so important about this average costs and the marginal cost? I thought we only need the total cost to calculate the profits. So at this point, yes, well, the average cost and the marginal cost may not seem to be very important to you. But when we get into the next chapter and start thinking about how firms maximize the profits, well, this average and marginal concept will become very important. Well, one more thing that I would like to go over with you guys is, since we talk about the average and the marginals, we also want to know about the behaviors of the average and marginals. And we call this the average marginal rules. Well, this can be explained by a very simple example here. Well, first of all, the rule of thumb is when we are adding an additional number to an average, let's say the marginal, which is the additional, is less than the current average, well, it will pull the average down. However, if we're adding an additional, which is a marginal number, to an existing average, which is greater than the average right now, well, it will pull the average up. Well, we can look at our GPA score and try to understand the relationship between a marginal and average. So for instance, let's say we are having a class, which is the math class that you're taking for this semester. You got a B in this class. So B is translate into a total score of 3 points. And that's why you're adding 3 points to your GPA and you got 3.0. And let's suppose you take a class, which is an English class, and you got a C in this class. Well, C is translate into 2 points out of the 4 point scales. So by adding the 2 points into your prior GPA, which is 3.0, obviously this additional score is lower than your current average. And that's why your GPA will be put down to 2.5. If you adding one more grade to your GPA, let's say a social science class, and you got a B from this class, and which translate to an additional points of 3.0, well, since 3 point is higher than the prior GPA 2.5, and that's why you're pulling your GPA up to 2.67. If you keep looking at these scores right here, of course, you can find a patterns. Well, whenever you're adding additional grades, you want to look at your current GPA before adding it, And when the additional grade is higher than your current GPA, well, then it will pull your GPA up. However, if you're adding A grades and additional grades or marginal grades to your current GPA, which is lower than your current GPA, then it will pull your GPA down. So why is it important to study this relationship? Well, if you look at the average costs and the marginal cost curve, well, you will note this patterns. So let's talk about this graph right here. As you can see from this example, we have the average variable cost curve, the average total cost curve, and the marginal cost curve plot into the same graph. As you note, the average total cost curve should always be above the average variable cost curve. And the reason is because the average total cost curve is the sum of the ABC and AFC. So the value of ATC is always going to be greater than ABC. And by looking at our previous examples, you might already notice at the beginning stage of the productions, when the firms start producing some amounts of quantity, well, the average costs are going to go down. And now we want to know why the average costs will go down. Well, it's all because of the marginal cost curve behavior. So as you can see, the marginal cost curve will decrease at first and then start picking up. The marginal cost curve had this behavior because of the diminishing marginal returns that we study in the productions. At the beginning stage of the productions, firms adding additional inputs in the productions will be super efficient, and that's why it will drive the additional cost down. At some point, because we're adding more and more variable inputs to pair up with the fixed inputs, well, the variable input will losing the efficiency, and that's why the marginal cost will start picking up. Well, as you can see, the ABC and ATC are both above the marginal cost curve at the beginning stage. So remember the rule that we studied? When the current average is higher than the additional grades or the marginals, the marginal added to the current average will pull the average down. So in this case, as long as the marginal cost curve is below the ATC or ABC, it will keep pulling the average cost curve down. However, at some point, because the marginal cost curve will pick up so fast, well, due to the diminishing returns, it will hit the ABC curve and the ATC curve at some point. And as you can see, once it hits the ABC curve, the next level of outputs will have the marginal cost higher than the average variable cost. Remember, the additional cost is higher than the current average cost. It will start pulling the average up. And that's why you see the average variable cost curve to start picking up. And once the marginal cost curve passed the ATC curve, the average total cost curve, it will do the same to this average. So as long as the additional cost is higher than the average, well, it will keep pulling the average up. And that's why we're seeing the behavior of the production cost in this following forms. Again, very important. You have to keep in mind, this is generally applied to any types of productions in our world. Regardless, we are talking about the productions of a software programs, or maybe a car productions, or maybe we are talking about how we run a supermarket. This cost behavior will always be true because the law of diminishing return is true. Now we are going to investigate how this cost curve will affect the decisions of the firms. And of course, we are not getting the full picture yet because we are only studying the cost of the productions here. We haven't actually put into the revenues parts. Well, before we getting too long away from this study, we would like to also discover what we mean by sunk costs. This is a very common term that people use to brought up in economics, and not many people actually understand it, or maybe most of the people misunderstood this and get confused with the sunk cost with the fixed cost. So sunk cost, it's basically a cost that incurred in the past that cannot be changed by current decisions. and therefore it cannot be recovered. So what are some of the examples? So for instance, if you are trying to get a franchise business from McDonald's or Burger King, most of the time, those companies will ask you to put into a sunk cost to buy certain things that represent their company. So for instance, those billboards that you see in front of the store, those are the equipments that it's required by the company to purchase by the firm's owner. So those are the costs that usually cannot be retrieved. So when the firms who join the franchise, they have to put in this money to buy those billboards to showcase their company names. And that's why, well, after they finish the business, let's say one day they want to quit the business, they will never be able to retrieve this cost from by selling the billboard to back to the franchise. Another types of sunk costs that's very often happens in the market. It's basically the cost for training workers. So staff training education programs supported by the company, usually those are the costs that the company pay, but they will never be able to recover. And the reason is because once the training is being distributed to the workers and the money is paid, company have no controls of how the employees will use the training's knowledge or how long the employee will stay in the business. So generally speaking, sunk cost has nothing to do with the decisions of the firms. Firms will not care about how much sunk cost they will have to pay once they start the business. The decisions of the firms will only be affected by sunk costs. It's when the firm start thinking about in the long run, when they think of whether they should exit the industries or maybe stay in the industry. And the general idea is the higher the sunk cost is, well, the more difficult for the firm to exit the markets. And that means, well, the longer the firms will stay in the industry, even though they are losing money. At this point, well, we have clarified a lot of the cost concepts in the short runs. In the next video, we are going to focus on the long run study and trying to understand how firms behave in the long runs. I'll see you guys in the next video.